Hello and good day. In pre-algebra, we'll be going over the rest of PO9 after first going over the integer section, which was the homework for today. So basically, what we talked about, there's the kind of standard way to show addition and subtraction, right? You've got just a plus sign or just a minus sign. And of course, I'm talking about what's in between the numbers. Okay. If you weren't here yesterday, don't copy this part down. There's much more that we did. So watch the video and get the notes, the complete notes from that. This is just kind of a summary of it. But between the numbers, if you're only adding, the operation is, of course, addition, which means that you are going to the right on the number line. Subtraction, your standard subtraction, is to the left on the number line. But what's kind of the synonym for subtraction? Another way to write it, to where if you see this between your numbers, it represents you're subtracting. What did we say? There's another way to write subtraction. Well, don't look at me. Look at your charts. Right? You all filled them out here. What is another way to represent subtraction? Aiden.
Division?
What? No, division is not subtraction. Yeah. Okay. Look at your charts. What did we put down? What other? Yeah, Connor. Right. If you're adding a negative, okay, and we see a couple examples of that here. 14 plus negative 3, negative 25 plus negative 8. Okay, that's another way to represent subtraction. So when you see that, you know that you're going to the left on the number line. Okay, let's put away. Let's decide on one snack to eat, and then put the rest away and take out the binders. So not only can we follow along, but we're not, Miss Crinkleton or whatever. Okay. What's another way for addition? Kind of a synonym for addition. Again, I will tell you to look at your charts. We all filled these notes in yesterday. Aiden.
Add a negative?
That's what we just had for subtraction. Subtracting a negative, okay, such as we see here in negative 4 minus negative 5, or 13 minus negative 13. That is another way to write addition. I will admit, I'm a little bit worried here going into the correcting phase of this homework, okay? Maybe we're just keeping our feelings inside today, but like to get feedback that you kind of remember and understand what we talked about in the first part of PO9. But we will correct. We'll see how it goes. Remember, you cannot use a calculator on this section of the test, and this being a key point. You can put this on a help sheet, but you need to know what these different symbols mean as far as the operation. Sasha.
Yesterday you had put the plus and the minus right under the plus at the top.
Did I? Sorry. I don't remember the order, but thank you. So the order might be a little bit different, but the concept is the same in that the two ways to show subtraction are either a negative or adding a negative, and then addition is plus or subtracting a negative, right? Because these two signs kind of cancel out. If you got a double negative in a sentence, it actually ends up being a positive statement. So negative 7 plus 9. Shout out the answer. That was a whisper. Shout out the answer. 2 is correct. Negative 7 plus 9 is 2. 13 minus negative 4. 17. 17. Please make your corrections if you get these answers wrong, and then identify why. Why is it 17 and not 9? This subtracting a negative, okay, you see that in between the numbers. You refer to the chart. You say, oh, that's addition. This is just like 13 plus 4. Okay, 13 plus 4, 17. Negative 5 minus 3, shout it out. Negative 8 is correct. 12 minus 20. Negative 8 again. 14 plus negative 3. 11. Negative 13 minus 6. Negative 19 is right. Okay? What we talked about yesterday is, that first number, I'll take this one here, that first number has nothing to do with the operation. Oftentimes folks see negative and a negative and they think, oh, I must be adding here. But what's between the numbers, right? Only one subtraction sign. So this is going to be subtraction. We'll be moving left on the number line, and the purpose of that first number is to just tell you where you're going to start. Okay? You're starting at negative 13, and you're moving to the left, because you're subtracting, 6. So what number is 6 to the left of negative 13? And that's how you end up at negative 19. If you put negative 7, you went to the right. You went over there. Okay? You added 6. Okay? So negative 19 is the correct answer. 7 plus 19. 26 is right. Negative 4 minus negative 5. Positive 1. Good. Negative 4 is where you start. You're subtracting a negative. So this is the same as negative 4 plus 5. So from negative 1, you go 5 to the right. From negative 4, you go 5 to the right, and you end at positive 1. Negative 9 plus 9. 0. 14 minus 6. 8. 22 minus negative 18. 40. Another addition one there. Negative 25 plus negative 8. Negative 33. Adding a negative is the same as subtracting. Negative 15 plus 31. 16. 12 plus negative 15. Negative 3. 0 minus 4. Negative 4. Right? That's different than 4 minus 0, isn't it? 4 minus 0, you're starting at 4 and not moving anywhere. 0 minus 4, you're starting at 0, and you're going to the left 4. So you're going to end at negative 4. 13 minus negative 13. 26. Negative 5 minus negative 20. Positive 15. Positive 15, right? That minus a negative piece actually turns into addition. So we have negative 5 plus 20. Starting at negative 5, going to the right 20, we end at positive 15. And lastly, negative 12 minus 17. Negative 29. Okay. I checked the question form prior to this. There weren't any questions about this stuff. So if you are getting several of them wrong, check to see which type. Is it primarily the situation where you're starting negative and you subtract? Are you moving the wrong direction? Is it the ones where you're subtracting a negative? Those seem to be the most common ones. Try and identify, don't just say, oh, I don't get this. Okay? Identify what your mistakes are so that you can kind of fine-tune your focus on that type. Okay? And then, of course, you can see me if you've got questions on that. But any questions for the group? No? All righty. Let's move on then to decimals. Decimals. What's the important thing to remember when you are adding and subtracting decimals? With integers, it was kind of the which direction are you going on the number line type of deal here. But what about decimals? Yeah, Sarah. Yes, place value is so important. When you've got 7.1 plus 12.6, if you write it like this, 7.1 and then 12.6, yeesh, you're going to get the wrong answer, right? Because what you're saying here is that you're going to add 7, which is in the ones place, to the 1 here, which is in the tens place. 7 ones and 1 10, that's not how we line these up and add vertically, okay? Make sure that decimal point is aligned in both decimals, 7.1, 12.6, and now you're adding 1/10 to 6/10. 7 holes to 2 holes, 7 ones to 2 ones, and then you have your 10 there, okay? So after you get that part of it down, it's really just vertical addition that you've learned before, but lining up that place value is important. So we've got 0.7, 7 ones and 2 ones, 9, and then our 110, 19.7 would be our answer. Okay? 19.521 minus 17.22. Remember that with subtraction, order matters. That first number goes on top. 19.521 minus 17.22. If you want to, just to make sure everything lines up perfectly, add a 0 there to fill out that thousands place. But now it's just that vertical subtraction, right? 1 minus 0 is 1. 2 minus 2, 0. 5 minus 2, 3. Bring down the decimal. 2. And then the ones cancel out, 2.301. Okay? So not as much to think about as with integers. Okay? A little more straightforward. But if you don't get those place values lined up, you'll find yourself in some trouble. Any of the other 6 that you want to talk about? We'll do one more together if folks want to. No? Okay. Let's do the next one then. 14.12 minus 3.65. I just want to bring up this one because, of course, this one has everybody's favorite thing with subtraction, borrowing, right? 2 minus 5, we're going to borrow a 1/10, and instead of writing that as 2/100ths, we're going to write it as 12/100ths, which is the same thing as 1/10 and 2/100ths, where they have 12 pennies or 1 dime and 2 pennies. It's the same amount of money, right? Just represented differently. So 12/100ths is the same thing as 1/10 and 2/100ths. But this gives us 7/100ths here. Now we're going to borrow from our whole. Make that 10/10ths, right? 10/10ths is equal to 1 whole. So it's the same thing, just represented differently. 10 minus 6 gives us 4. And 3 minus 3 is 0. 1 minus 0 is 1, 10.47. Right? So just remember that borrowing piece. You might run into that in some of the other subtraction ones. Okay? Did you know it's actually possible to subtract without borrowing in that situation? Anyone interested in seeing how? Yes, a couple of hands? Okay. So I'm just going to pretend this one isn't here. I'm going to redraw or rewrite this over here. But if we have 14.12 minus 3.65, okay, 2 minus 5 doesn't work, right? We have to borrow, okay? And actually, just to keep this simpler, since it's the first time that you're seeing it, I'm going to take out the decimals and just think about it as 1,412 minus 365. Okay, so 2 minus 5 doesn't work out, right? Okay, but what is 2 minus 5? -3. I can write that down here as my answer. Okay, and then when I move to my 1 and my 6, I'm not going to think about that as 1 minus 6. I'm going to think about it as 10 minus 60, because really that's what it is. You know, that 1 is in the tens place, that 6 is in the tens place. This is 65, you know, and then 12. So what's 10 minus 60? Not 50. 10 minus 60. -50. Okay? And then, not 4 minus 3, but 400 minus 300 is what? 100. And then 1,000 minus nothing is still 1,000. Okay? And that 100 was positive, so I'm going to put a plus sign there. So now, 1,000 plus 100 is 1,100. Minus 50 is 1,050. Minus 3 is 1,047. Which is the same thing that we got here, but I took out the decimals, which is why it's 10.47 versus 1,047. But this is a way to subtract without borrowing. You just literally write what the answer is, and then this is the equation that you solve to get the final answer. So, fun fact for you. But yeah, there's a question? Oh, you were just wooing and impressed? Yes.
Where'd you learn this?
I think I first stumbled upon it in college. Yeah, because I was taught the whole borrowing thing, But the funny thing about that borrowing thing, if you were to ask, your parents what you're actually doing, a lot of them might not really know. Like, well, it's just what you do. Okay, some I know, but a lot of them, it's just what they were taught. They weren't really explained what we're doing, And what we're doing is that, like, when we borrow here, when we went back to this step here, cross out the 2 to make that 12 there, what we're doing is we're taking 1 dime and 2 pennies and rewriting it as 12 pennies, essentially. We're taking those equivalent values so that we can take 12 pennies minus 7 pennies, But it was in a book about, like, how to teach subtraction, and I really like it. But anyway, that's, yeah. Questions on decimals? Okay, very good. All right. Line up those decimals, line up that place value, and go to town. Fractions. Yes. Everybody's favorite, right? Right? I love fractions too. Okay? Tell me what you know about them. When we get ready to add and subtract fractions, tell me what you know about fractions. What must you remember? What are your key points, Kira, that you're probably going to want to put on a help sheet? Right? Aiden.
The denominator should always be equal.
The denominator should always be the same. Why is that? Why is that? It's just one of those rules that you're told growing up, but why is that, Aiden?
So you can, it makes it easier.
Okay. I mean, wouldn't it be easier if we didn't have to find common denominators? Actually, wouldn't it be easier if we could just add these to be 9/18ths? It's not easier to find common denominators. That's not why we do it. We do it because we have to. But what's the reason why? Yeah. Not so much make the fractions equal.
Simplify the fraction.
Not really to simplify the fractions. I mean, what does the denominator of a fraction tell us? When you get a test score back and it's 28 out of 30, what does that 30 represent? Here's the whole, right? How many make up the whole? And so 2/12, that 12ths is how many pieces there are total. How many things make up the whole? It's a thing. This would be just as proper to say, I'm taking 2 chairs and I'm adding 7 tables. Right? The denominators are just things. And if I said, what's 2 chairs plus 7 tables? You wouldn't tell me that's like 9 tables. Would you? You can't combine that. You can't add chairs and tables together into one thing. That's not how things work. Okay? If you were a zookeeper, and I bring up the zookeeper example because my son, who is turning 5 shortly, but he wants to be a zookeeper when he grows up. And to him, growing up means when he turns 7. And he can ride his bike to the zoo that he owns. But whatever, I'm not going to crush his dreams. But anyway, as a zookeeper, you would not add penguins to the lion's cage, would you? I'd hope not. That would not end very well for the penguins. Okay? You can't combine things that aren't the same, right? And so it's important to have those common denominators so that we are combining the same thing. Okay, in this particular example, we can either get 12ths by changing the second fraction, or we can get 6ths by changing the first fraction. Okay, which one would you like to do? Let's get someone that hasn't participated. John, what do you want to do? No, sorry. I'm still on the first one here. Do you want to change our denominators to 12ths or to 6ths? Pick one. Do you want to change it to a 12 or to a 6? 6, fine. So in this example, because we can reduce 2 12ths to be 1/6, and we do that by dividing numerator and denominator by 2, okay? Now we're in business. 1/6 plus 7/6. Okay? Those denominators are the same. We're adding penguins to penguins, lions to lions, chairs to chairs. We're good. Okay? Now, why don't we, and actually, you know what, there's just, why don't you sit here today? Pierce, you can move over here. Just too much side conversation going on there. Okay? Why can't we add the denominators to get 8 12ths here? Why doesn't that work? This is the second thing to remember with fractions. The first thing is that the denominators must be the same. The second thing is that they stay the same. We're not going to get 8 12ths here. Why? Sarah? We are going to need to simplify, but why don't we add the denominators when adding fractions? Yeah.
Because then it wouldn't be the whole.
It wouldn't be the whole, right? The whole doesn't change, okay? If you add 1 lion to 7 lions, you don't get 8 mega lions, super lions. No, the lions don't change, just the number you have changes. So 1/6 plus 7/6 is still going to be 8/6. Okay? That doesn't change. And now, as someone said, we do need to simplify. So we would divide by 2, divide by 2, and our final answer would be 4/3. You do not need to come up and ask me if you need to simplify your fractions, right? You wouldn't go to Mr. Olson and say, Mr. Olson, so I'm writing this essay for your class. Do you want me to use punctuation in my paper? Like end my sentences with a period and questions with a question mark? Do you want me to do that? Of course he does, right? You simplify fractions. Oh, it's just what you do, okay? It's what you do. So no need to ask. The answer will always be yes, all right? Okay, so that was a really long, lot of metaphors, a lot of jokes, metaphors to say when you add or subtract fractions, make sure your denominators are the same. You have to make them the same. Don't be adding penguins and lions together, okay? And then your denominators stay the same. Stay the same. So, John, you had brought up one earlier you'd like for us to do together. Which one were you talking about? Sure, mixed numbers, yeah. So for mixed numbers, this is a situation where we have a whole and then a part. We have 2 wholes and then 2/5. And we're subtracting 1 whole and then 9/10. My recommendation is to convert these to improper fractions first. Okay? So what's the math behind converting 2 2/5 into an improper fraction? There's a shortcut way, and then there's kind of like a mathematical way, like the math behind the shortcut. Aiden, what do you remember?
5 times 2 and you add 2.
Okay, so the shortcut is that you multiply the denominator by your whole, and then you add the numerator, right? So 5 times 2 is 10, plus 2 gives you 12, and your denominator stays the same. But why does that shortcut work? This is another situation where, this is what you were taught to do perhaps, but why does that work? Why can we do it? Aiden?
Because if you were to convert it into a mixed number, if you were to convert it in cross fraction into a mixed number, you would see how many times the denominator goes into it.
Sure, yeah. Converting back, we would say how many holes do we have here? 5 goes into 12 2 whole times with 2 left over. That's how we get 2 wholes and 2/5. But this shortcut, why does this shortcut work? How many fifths make 1 whole? How many fifths make 1 whole? 5. Okay? So 2 and 2/5 is like saying we have 1 whole plus a second whole plus our part, that 2/5. We can also say that since 1 whole is equal to 5/5, we have 5/5 plus another 5/5 plus our part of 2/5. And if we look at that expression, how many fifths do we have in all? 5/5 plus 5/5 plus 2/5 is a total of 12/5. Okay? So what we're doing is we're saying, well, if we think about these 2 wholes in terms of fifths, how many would we have in all? And the shortcut, of course, is to multiply. Well, 2 times 5 gives us 10. 10/5 in those 2 wholes plus our numerator, and that's how we get the 12. Okay? I'm not saying you have to do it this way, right? The shortcut is there for a reason, it's shorter. Yeah. But that's why it works. Okay? That's what's really going on behind it. So anyway, 12/5, John. And then what would 1 9/10 be as an improper fraction? Carly. Sorry? 19/10. So we have 12/5 minus 19/10. Okay? Are we able to subtract them as they are written? Why not? The denominators are not the same. So how do we get them the same? In our first example, we had the option of either going to 6, which we did, or we could have gone to 12 also. In this case, not quite so much. Our options are more limited. So what do you see? You've probably heard the phrase least common denominator before. That goes hand in hand with CO7, what we did the last unit, least common multiple. What's the least common multiple of 5 and 10? I'm going to give other people a chance. Thank you for always wanting to participate. But what's the least common multiple of 5 and 10? Yeah, it is 10. Okay, one fraction is already written with the denominator of 10. The other one, we're going to have to multiply both 12 and 5 by 2 to get there. So we get 24/10 minus 19/10. Okay. Now we're in business. 24/10 minus 19/10 is how many tenths? Carly. 5/10. Final answer? Right? No. Pierce?
1/2.
Simplify down to 1/2. Okay? John, is that good? All right. Yes?
I have a question. Can't you just minus 2/5 and 9/10 and then add 1 to 2?
Let's try that. So Aiden's suggesting, can't we just kind of ignore the holes, take 2/5 minus 9/10, right? Which this would give us, multiply by 2, 4/10 minus 9/10, which would 4 minus 9 is negative 5/10. And then do what?
3 and 1/2.
3 and 1/2? Well, that's a negative 5/10 right now.
Oh, 1 and 1/2.
How would we get to 1 and 1/2 from negative 5/10? Okay. Well, how we get there is that, yes, if we just ignore the wholes and subtract the fractions, we get negative 5/10. But now we look back at our wholes. What's 2 minus 1? Oh, come on. What's 2 minus 1? 1, right? So we have 1 whole, and then we have our negative half. What's 1 minus a half? A half. So the answer to the question is yes, you can do it that way. However, pay attention to signs and things such as that. Okay? Unless you are comfortable with that, then I would recommend doing it the other way, but that is a way that works. Okay? Any questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this? Yes.
Congratulations.
On? What did I do?
Father.
Oh, thank you. Yeah, well, thank you very, very much. Anything else? All right. Your homework is to finish PO9, which is just the decimals and the fraction section. It will be due on Monday. You've got about 7-ish minutes to work right now. And that, folks, is how you math.